Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. I'm not sure how long it's gonna take, we'll see. And today's puzzle is called Second Rodeo by James Sinclair and Tallcat. Actually, I don't remember, I think I might have solved the first rodeo puzzle on this channel. I don't know. Maybe I did, maybe I don't. If I did, I will post a link to it up in one of the comments, so that you can actually try James Sinclair's first rodeo. And it's basically a chaos construction, which is similar to this one, which is why I guess he called it second rodeo. Anyways, this is called second rodeo, and let's get to the rules. The rules are divide the grid into 9 orthogonally connected 9-cell regions and place the digits 1 through 9 once in each row, column, and region. And this is called chaos construction rules because you're constructing the region through chaos. I think that's why it's called chaos construction. Anyways, I know it's just called chaos construction. Construction makes sense. Chaos, who knows? Maybe there's a reason why. Um, but that's chaos. This is normal chaos construction rule set, where basically you have to construct the regions themselves. And they have to be orthogonally connected, which means that they must share an edge to all the rest that connects them to all the rest of the cells in the region. So this is a valid example of a constructed region. This would not be, because this is not orthogonally connected to the rest of the region, right? Because it's only diagonally connected. And orthogonally connected, I should say, specifically, just means that they share an edge, right? So this is not orthogonally connected because they don't share an edge, but this is. So this would also be a valid region to construct. And that's chaos construction rule set. We also have a digit inside a circle indicates the sum of all digits in the same region that see that cell by knight's move. Oh, okay, yes, I do remember something similar to this. So I think I did do the first rodeo puzzle. Um, I think it was very fun, actually, if I remember correctly. But basically, this digit in the circle indicates the sum. Actually, let's just choose this one because that makes it clearer. This is the sum of all digits that are in the same region that see that cell by a knight's move. And a knight's move is basically just two cells over and then one cell in a perpendicular direction. So for this specific circle, a knight's move would be in these 8 cells. Oops, I'm not shifting while doing this. So it would be these 8 cells added together if they are in the same region. So that's very important. So for example, let's say that these 3 cells were in the same region as this one. Well, then this would be the sum of these 3 cells. And it could be something along the lines of, I don't know, 1, 2, 4, and then this would be 7, right? And obviously, none of the other cells that are knight's move apart, since they are, we are assuming that those are not part of the region, so therefore they would not contribute to this sum. But that's what the digits inside a circle indicates. Digits inside a square indicates the total number of cells in the same region that see that cell by knight's move. So, let's take a square. This is a square with the most that has. So whatever digits that are in the same region that are a knight's move apart, they would count toward that's added one by one to the number that's in this cell. So if it were these three cells, say, that were in the same region, so these were not, right? So these were not in the same region, these were in a different region, then this would have to be a 3 because it has to essentially count the number of digits, sorry, cells, not digits, cells that are in the same region that are a knight's move apart from it. And that's what squares mean. And finally, we have a digit inside a diamond indicates the total number of other regions with at least one cell seen by the knight's move from that cell. So it's essentially, it's not the same as a circle and square. It's kind of the inverse, but not completely. But basically, whatever this cell sees by knight's move, you count how many other regions with at least one cell seen by this with a knight's move that are a knight's move away, shall we say. So say these two were part of a different region. This was part of another region. This was part of a totally different region. And say these two were part of the same region as this center one. And then this one was part of, oops. These two were part of the same region. Well, you count how many regions have a cell that is a knight's... again, these were part of the same region as this central cell. But you count out how many regions contain a cell that are a knight's move away, that are other regions. So you do not count the same region, which would be the green here, right? So this would be 1, 2, 3, and 4. So therefore, this would have to be a 4 in this example, right? Because it doesn't count its own region, but it counts how many other regions have cells which are cells which are a knight's move apart from it. And those are all the rules. If you'd like to play along, there's going to be a link in the description. I'm not sure how long this is going to take. You will be able to know because you will see how long it takes. Well, actually, I might break it up into two-part videos because I sometimes do that. Because I usually don't do very well, actually, after 2 hours of trying to solve a single puzzle. Anyways, those are all the rules, and if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. The one thing that my eye is drawn to is specifically the one in this corner, which has a diamond and a square, but there's no circle. So it has a diamond and a square. So it has to be at least 1. So a digit inside a square indicates a total number of cells in that region that in the same region that are a knight's move away. So there's at least 1. And then the digit inside the diamond indicates the total number of other regions with at least 1 cell. So that also must be 1. So one of these is in the same region, and one must be in a different region. So this has to be a 1 then. This is similar, but there's possibly 4. It could be 1 and 1. Right? This could be 1 that's in the same region, and then one other region contains all 3 of the other knight's moves away. Or it could be 2, right? It could have 2 in the same region, and then 2 other regions containing 1 from a knight's move away. So this is 1 or 2. A digit inside a square sees the total number of cells in the same region that see. So this is also 1 or 2. And this cannot be 3, right? Because if this is 3, that means 3 of the knight's moves are in the same region, But it's not possible to have 3 different regions then, because you only have 1 extra knight's move, which can be used by another region. This also has to be 1 or 2 cells that can be seen by a knight's move, because it only has 2 possible knight's moves away in this corner. So similarly, this has to be 1 or 2. The digit in the diamond equals the total number of other regions. So this has to be then 2. And therefore, this has to be 1, and therefore this has to be 2. So this one has 2 knight's moves that share the same region. We don't know where. And then 2 other regions which have a cell that's a knight's move away. This has to be 3 or 4, because it can't be, we have already 1 and 2 in the same region, or in the same row. And this square then indicates that it sees at least 3 in the same region. Can it be 4 is the question, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes, it's possible. Unlikely, but possible. All of the squares, this also has to be 3 or 4, because again, it sees 1 and 2 already in its row, and it can only have at most 4. So one of these does have to be a 4. That's interesting. And that means 4 of these cells can only be, have to be in the same region as it. Huh. This must be a different region than that. So this, I don't think this can be the same as either of these, right? Well, This requires at least 3 being in the same region. What's the minimum here to do that? I think it's this, right? You need to connect these, so you have essentially 3 here, or it could be like 3 here, right? To connect this to this center one, you need essentially 4, 5, and then 6, 7, right? 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, 8. Well, but this could be 7, right? 1, 2, 3, 4, 5, 6, 7. Well, the problem is you can't extend 2 more to the rest of it. So therefore, these have to be different regions. So this is a different region than this, which is a different region than this. This has to be a different region than this. Is that right? This also has to be, yeah, it cannot extend all the way here. But this could be the same region as this one, though. So we're going to make these different, and then we're not sure about this one. Okay, so neither of these are in the same region as this one. This must have 2 that's the same region. Okay, that's interesting. Okay, so this... that's not helpful there. These diamonds all have to essentially be 1 through 8, right? Because you could potentially have 8 different regions. which are knights move away. But this specific, okay, so this can't be 1. And this only has how many knights moves? This one, and this one. Oh. Well, this has to be specifically 3 then. It can't, or, no, it could be 2. So this is 2 or 3. Never mind. This is 2 or 3, which means the knights move away has 2 or 3 other regions in it. This could be 2. This can't be 2, though. This has 8. This could be up to 8. The square, this one only has 6 at most, so this has to be 1, 3, 4, 5, or 6. I mean, this cannot be the same as this one, because, and again, this can't be the same as this. If this were 4, what does that mean then? That would mean these would be all the same. Which means this one technically could go something like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. It could go something like that, in which case you could have still 7 other regions not containing it. But that doesn't really tell us much. Well, we have a 3, 4, 3, 4 pair in column 5, so that eliminates 3 and 4 from the rest of the column. So it has to be 1, 5, 6, 7, 8, or 9, and 2. But this can't be 2 specifically. This obviously can't be 1 or 2. Oh, right. I seem to recall... Right. I seem to recall a rule set. Or not a rule set, but something that... Essentially a shortcut with regards to the circles. Yeah. So this is why it's important. I guess this is good to go... I probably would suggest, if you're trying this, to first try first rodeo, because there are definitely... I vaguely recall now a certain shortcut from the first rule, for the first rodeo, where if you have circles that are knights move away from each other, they cannot be in the same region. And the reason why you know that is if these were in the same region, well, this is essentially the sum of these digits. So say these were the same region, right? The problem is this is included in the sum of all digits that are in knights move away that are in... Okay, and that's another thing about the sum. The sum of the circles always must have 2 other cells, right? Because it has to have 2 cells in the same region. If you tried to have 1 cell in the same region, then they would both be the same number, and that doesn't work. So anytime you have a circle, it must add up to with 2 specific digits in the same region. Well, the problem is then, if these are in the same region, this is essentially the sum of this plus another number, but then this has to be the sum of this plus another number, and that's a contradiction, right? You can't have this being like a 5 and this being a 6, because then this 5 says, oh, well, it adds up with another digit, 1, to add up to 6, or it can't, right? You would have to have a negative number to add up to 5 from a 6. So that's why anytime you have a circle, you know specifically that it cannot contain... if you have 2 circles that are knights move apart, they have to be in different regions. So this one then has to contain two cells that are in the same region that our knights move apart. Well, cannot be these two, so it must be these two. Well, this green actually could still be part of this red region, right? It could go something funky like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this actually could be part of the red region. It cannot be part of the white region, though, because this is saying that it has to be a specific other region, right? This is likely part of the medium gray region. So we don't know which one this is connected to. But this specifically has to be these two cells. What about this one? This one cannot be part of that region. So this one, we're going to make this red because it's very likely red. Has to be has to be the sum of these two regions. Because otherwise, yeah, it cannot be part of this region. It's very likely red, but we don't know. So if this green is the same as the red region, I don't think that works, right? It would have to be all of this. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, this could be green. We're going to make this orange, its own separate region. So the green, okay. Right, because this must cross this way if these are separate regions. That's interesting. So can the green actually be part of the red? Well, the only way it could is if it connects to the orange. If that's the case. Right? Because this blocks off the orange from itself, right? Because again, each region is orthogonally connected to all the rest of the cells in the region. So if this were the case, it has to be part of the orange to be connected to the red. But the problem is, what's the minimum? Okay, this could, well, no, this has to be part of a region, so it'd have to be part of the green. So you could have that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, can it ever be part of the orange? Ever? Maybe. Let's see if it connects. So this would connect that way. It could connect here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So orange could be part of the green. Oh, wait. But that's problematic, right? Because then it takes over all the diagonals of the red region, right? And we know there has to be one and only one cell that's in the same region that's a knight's move away. So then, yes, green and orange cannot be the same region. And orange actually has to be part of the red region. So I was correct in my assumption that the red had to be part of the that this had to be part of the red region, essentially. Now, how does the green connect? Well, this red has to go around, and this green has to connect this way, at least. So it connects this way. This red has to go around, so it goes around here. This cannot be part of the region, so it has to go all the way around here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that's not good. We have a problem here, actually. That's problematic. This cannot be part of that region. But this has to have the two... Oh, no, never mind. Okay. My bad. This, again, has to have two. It has to be... We just showed, actually, this is not allowed. Right? But it could be this... No, it cannot... Okay. So I think no matter what, this circle cannot be part of the green region, right? If this were, let's say it was with these two. The problem is you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? If this circle were part of the green region, we know this is part of the green region because neither of these can be. So this one has to be part of the green region. To connect this, you could have this and then say you had these two as the region. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And say we remove that one and we made that one the region, it still has to be 10. Actually, it doesn't have to connect here. But the problem is with this, then, is that it blocks the red from forming a valid region in itself. So we know this cannot be part of the green region. Therefore, this must have, even if it connects this way and then this way, the problem is it has to be part of the red region, right? So then it would always connect with that one. So the question is, can this be a region by itself, right? We've shown it can't be part of the green region, right? Because it has to have 2 out of these 3 be in the same region. And the problem is that would require 10 cells for the green region, or it would require it to block the red region from ever getting out. So that's not possible. Well, can it ever be an independent region, right? No. Because the problem is it would have to have one of these two, obviously, and it could not have that one because then it would block the red from ever being a region itself. So it would have to go this one, and then we've shown this is already, how big is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to reach this one. Because it can't cut through, because the green has to connect also, and the problem is it can't connect through here. So it would have to get through somehow here, but then this is too long, right? Right here is 9 by itself, so it cannot go here, because then this would exclude that cell. So this must be part of the red region. So this is part of the red region, therefore it must connect with there. This has to be, and it cannot connect with that, so it must connect here too. So these are all part of the same region. This could be, I guess, still. This cannot be part of the red region, and it can't be part of the green region, so we'll make that part of the pink region. Okay. This is either part of the red region or the yellow region, right? Okay, this cannot be part of the yellow region. We've already figured that out, right? Because this has to have at least 3 of these Knight's Move, which are part of its region. And if this was red and part of its region, it wouldn't work. So this must be then 3. So this is 3, which makes all of these yellow. Therefore, this is 4. And so all of these are the gray region. The medium gray region. Okay. Therefore, this is not part of... This could either be, again, yellow or red, right? So if this is red, this would be 1, 2... This would have to be part of a region. So it would have to go here. Or this is yellow. And if this is yellow, this would have to be yellow. So this is red or yellow specifically. This is 1. These two add up to... So whatever these are, this adds up to. This cannot be... This has to be at least 4. So that means this is at least... Well, it can't have a 1 here in this region. This can't be 2, so this is at least 3. So this is at least 7 here. So this could be 4, 5, or 6. And this could be 3, 4, or 5. To add up to 9, right? These two could actually be part of the same region. This is not part of the gray. It could potentially be part of a completely separate region. This is 1, 2, 3, 4, 5, 6. It could be 7, 8, 9. That's possible. And then this would, but okay, no. If this is part of the same region, this square indicates the total number of cells in the same region seen by that knight's move. If it connected to here, and this was red, well, part of the problem is that the green couldn't connect. And this has to be yellow. This can never be part of the yellow region because that's too many cells in that region. So this one does actually have to go this way. So it has to go here. So this is at most 1 here. So it could be 1, 2, 3, 4, 5, 6, 7. Therefore, you need at least 2. But we don't know which ones those are. So if this is red, this would be 1, 2, 3, 4, 5, 6, 7. It needs 2 to be in the same region that our knights move away. So it would have to be red, red. Either way, then this would have to be yellow. If this is yellow, this would obviously have to be yellow also to connect to the yellow region. And if it's red, this has to be red, which forces this to be yellow. So we have 1, 2, 3, 4, 5 already yellows. This has to be red or yellow also, because otherwise it's surrounded by red and it's surrounded by yellow. This is obviously a separate region. We're going to draw the boundaries there. This is a separate region. So this is not part of the dark gray region, right? So this must be a dark gray cell for the square, right? Because it must see 1 that is part of its region, and it sees 1 that is owned by another region, which is the medium gray one. So this has to be dark gray. This is medium gray. This cannot be 8 anymore because this has to be, which is a knight's move away, has to be part of its same region. This could be the green region, or it could be the light gray region. It cannot be some other random region because then you can't form a region by itself. So this is green or gray. We're not sure which. Not gray. It's light. Green or light. This is gray. So I'm gonna call these light, gray, and dark. Even though these are all gray too, because it makes it easier to say. This cannot be green. Can it be part of the medium gray is the question, right? 1, 2, 3, 4, 5, 6, 7. This is the minimum, right? 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it would be 9. So this cannot be part of the gray. So it cannot be green, cannot be part of the gray. If it's light, it would have to expand quite a bit here. And that would block the green. So no, this can't be light. So it's either pink or it's some other region. We're not sure. Where is the light actually going? So the light can go up to here, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. It cannot go here. This has to be green because otherwise there's no other path for this green to connect. This is a separate region no matter what. So we know then this is 1, 2, 3, 4. We know we need at least 4 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these all have to be light because otherwise it just doesn't connect. So that makes that 1 at least. This must connect this way then. So this has to connect here. This must connect here because there's no other way. This could extend here, so we're not sure about that one. But we need these 5 at least. Because there's only 4 spots left for this light gray region. So this is not... This is a different region. This is a different region. So we have 1, 2, 3, 4, 5. Okay, this cannot be 4 because it's part of the same region as the 4. This has to add up to 4, and then we need another region, another part. So it's probably that one at least. Um, Oh, what if this were yellow, right? If this were yellow, this could be red. So this is 1, 2, 3, 4, 5, 6. I guess it could be 7, 8, and 9. Yeah, that's valid. So doesn't this have to be red no matter what? Yeah, I think this has to be red no matter what. If this is red, it obviously has to connect to this one because we need 2 that are essentially a knight's move away from this one. But if this is yellow, there's only space for these anyways. So therefore, this would be red no matter what. So this is red no matter what, which means this is not part of a region, and this is not part of the region. Let's see. This... Okay, if this were green, the problem is it would only connect, it would have a knight's move away from only one cell possible in the green. So this can never be green. This has to be light. So this is light, which means this has to be... We see 1. This is not valid. This is not valid. We have to see the other one. So therefore, this has to connect all the way here. So this has to be the region. Oh, let's do the complete border. So then this is the full region for gray, right? It sees 2 here, and, right. So then this has to connect here for green. We have 1, 2, 3, 4, 5, 6. This can only go 7, 8 if it's not, doesn't go this way. So therefore, this is always green. So it could be 1, 2, 3, 4, 5, 6, 7. We only have 2 other spaces possible here. So what is this? The digit in a square indicates the total number of cells in the same region that see that cell. Okay. It cannot see this. It cannot see that. It cannot see that. One, 2, 3. So either it connects here. 1, 2, 3, 4, 5, 6, 7. And it could be only 8, 9, 8, or 8, 8, 9, or 8, 9. It could connect this way and then that way. But either way, this is always 1 then. So this is always 1 because it will only see one cell it can only see one cell that is from the same region. Oh, and if it goes this way, that blocks. If it goes this way, it blocks because it can't be yellow. So it cannot go this way, so this one must be a green. And since this is green, this can no longer be yellow. Because if this were yellow, this would block it this way, and then this would be 1, 2, 3, 4, 5, 6, 7. 8 at most. So therefore, this has to be red, which forces this to be red. And therefore, we have the full length here. So that's the boundary for that. This can't be 1 or 2 because of what this is. This cannot block off this way or this way. So again, that's why it had to be here. We know these are part of the same region. So this has to extend here. And if red cannot go here because this already has 9. So this can only be yellow now because all the surrounding cells are yellow. This has to be green because that's the only green left. And that's, I think, 7 right? Or 9, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes, so that is the end of that region. Okay. This can no longer be 1. This can't be 1. This is the sum of these 2 cells, which neither can be 1. So this could be up to at least 5 through 9. Then this is 2, 3 through 7. Yeah, for those 2 regions. This one, none of these regions can be Knight's Move apart, and it can't be part of the same region as that. So this must have specifically these 2 regions as a Knight's Move to add up to. So this has to be pink, which means this is also pink. So this is pink too. This also has to add up to with these 2. So this is specifically here. This can no longer be 9. It can't be 8 because we have 2 digits that are higher than it in the same region. This can only be pink because it's only what it's surrounded by. Okay. So this has to conclude a 5, a 6, or 7. So this can only be 1 through 4, and this can only be 1 through 4 to add up to this number. This is a separate region. This cannot be pink. It could... Okay, no, it has to connect somehow to the yellow, so it must connect through here. This is already the sum of 3 cells. And this... Oh, not good. No, 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 that's bad. That is very bad. Okay, so I messed up somewhere here. Because again, this does have to be 2. This is 3. But this is a sum of 3 digits, which these are at minimum 4 and 5. So that's already 9. And therefore, it's a third digit here. And this has to be a digit because it has to have 3 digits, which it's next to. Okay, where did I mess up here? That sucks. I messed up big time. And I don't know where. Because all the logic seemed to flow very specifically. Um... Okay, this logic I think makes sense, right? Okay, so digit in a dime indicates the total number of other regions, right? So it's either, and then digit in a square indicates the total number of cells in the same region. So this is 1 and 1, so this has to be 1, which makes that a 2 because it only sees 2, and therefore it's 2 other regions, which makes that a 1 because, again, it could either 1 or 2. So it has only 1 region, so it has to be here. This has to have 2 specific regions, and it can't be either of these. So that's fine. Again, this can only it's a square and a diamond. So cannot have 3 in that because it would be digits inside a square. This cannot be the same region as this because that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in that region if that were the case. And it would block off this region, so that doesn't work. This is very bad. Shoot. This has to be 3 at least. Oh. Shoot. I think that logic was all correct, but the problem is that it's leading to me to a definite impossibility here because this is 4 and 5 at minimum, and this is, and that would actually make this 6, which would make that 3, which would make that 9, and this would be greater than 9. That is bad. What am I missing here? What am I missing here? What did I mess up here? Because obviously I messed something up. Okay, I'm gonna have to go through this with a comb. Very detailed. Okay. A digit in a square indicates the total number of cells in the same region that see that cell by Knight's move. And we know there's at least one. Digit in a diamond equals total number of other regions with at least one cell seen. And therefore it has to be 1. So this must be 1. This is again 1 or 2 because it only has 2 here. So it must be 2 here. This is 1 or 2, this is 1 or 2. This has to be 1 or 2 also, so this must be 1. And that's the number of cells seen in the same region. This, again, because it's a square and a diamond, must have indicate the total number of regions. So it's 1 or 2. It cannot be 3, cannot be 4. There are only 4 of these Knight's moves. And so this must be 2. This again, so this has to be 3 or 4, and this has to be 3 or 4, because it only has 4 knights moves away. This only has 4 knights moves away. You have a dark, you have a light. We're going to make this green. This green must be connected to here and here, because it cannot be these two, because then they would add up to each other. This is separate. This is yellow. Because this cannot be part of the same region, right? We tried to make this all part of the same region. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they cannot be ever part of the same region. So these are separate regions. What about this? This, again, has to have 2 digits, and we tried to make it around here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it cannot go all the way around here. So this must be part of these two, because it can't be part of here, it can't be part of here anymore. We've shown that. Oh, we didn't. Okay, so double check that the green has to be part of the same region, that this cannot be part of green, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, but it needs this. This is not part of any region then, which is not allowed. That's the issue there, right? If it connects this way, so actually, I guess it could go this way. Huh, maybe I messed that up. Maybe this actually has to be part of that region then, that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think that's where I messed up. This is actually valid. Hmm. No, it's not valid because one of these has to be part of this region. That's the reason why it's not valid. And then if it goes this way, it cuts this off from the region that it would form. So yeah, it's not valid. This then can never be part of green. So this always has to be part of something else. Well, if then it cannot go through here, so therefore it does have to go this way. So this is red because this has to have 2 digits that our knights move away that it can add up to. This has to go this way because it can't go. This is a separate region. Similarly, I don't think it could go anywhere around here. Yeah, it's just gonna be weird. This is already 9 by itself, so it can't go this way. So it must go here. This is not part of this yellow region, so therefore we know this is 3. Ugh. This is not part of red. That's another thing. So this can never be part of red because this is part of red. So this is part of a separate region. This is part of a separate region or that. This is 4. Again, if this is green, it cannot be part of these two. This can only contain... We have 1, 2, 3, and 4 here. So it has to be these. So then this has to be part of the light region. It can only go here then. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so this is the full region. which means this gray has to connect this way, and then has to, doesn't have to go this way, but I guess it could be part of this region. The problem is this. The problem is this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One, two, three, four, five, 6, 7, 8, 9, right? And this has to be yellow. Oh, not good, not good. Why is this? Oh, I'm running to the same issue. Right, this has to be one. Okay, this has to connect this way. And it has to have one. And the problem is... Oh, I guess this could be part of gray. Okay, maybe that's where I messed up. Okay, maybe that's where I messed up. Okay, so I see a light out of this tunnel. This... So again... This, I think, has to be red. It could go this way, though. So that could save us. And in fact, actually, I think that forces us to go, this has to be a yellow too, right? This actually could be gray, right? I actually messed up. This could actually be gray, and I think that's where it has to go. We just showed we have a problem here, right? If this is yellow and then this is red. So we just showed this is problematic. Right? This is 9. And we chose to go this way instead, right? It has to continue this way. So this one is definitely has to go green here, right? Because there's only 1, 2, 3, 4, 5, 6, 7, 8 choices without going this way. These cannot be part of green. But if we go this way, that actually does work with this being gray. And this can be gray, essentially. I think. That's a little problematic. 1, 2, 3, 4, 5, 6, 7, 8. No, this can't be gray. Oh, no, we still run into the same problem. I mean, it could be yellow, maybe. Oh, no, it just doesn't seem like it works that way. Oh, no. This can't be gray. We just tried it, right? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And then this is 9 is not connected, if that's the case. So this can't be gray. But this has to extend somewhere here, right? And this has to extend, but it could if this were yellow, but the problem is if this is yellow, how does it connect this way? This has to be gray because it has to connect somehow, right? Because this one is only stuck specifically this way. Mm. 4, 5, 6, 7, 8. Hmm. These just can't be in the same region. This has to be a yellow because it has to have a 3 at least. One, two, three. If this is 2, if this is red, it has to go here. Can't go here because that's blocked by that. This has to be part of that. Five, six, seven, eight, 9. But then it blocks that off, or blocks this off. Ah. This. Ah. Mmm. This has to be yellow. But then, okay, so this can't be yellow here, if that's the case, right? This is 4, 5, 4, 5, and that would be something else, right? Maybe this we can say this somehow. I don't know how, but uh, so this cannot be red. It has to be yellow, which means this has to be yellow. But I keep running into the same problem. This is 7. This has to be red and red, but then this, the total number of cells in the same region that sees that cell by knight's move, it would be 0. Because it blocks that. It has to be gray. Uh, 1, 2, 3, 4, 5, 6, 7, 8, and then it's one of these two. This doesn't work. Because this would have to be red and this would be red, and that's not, doesn't work because this breaks. Okay, so this is problematic because this has to see those two cells because it cannot be these two. So that is there. So it cannot be green because of that. This then has to be green, and it cannot be that one because it sees there. This one is specifically has to connect somehow, so it connects, so it has to connect that way, so that can't be green either. This can't be because again it has to connect somehow, and this can't be because it connects somehow, and this one is not because it has to contain 2. So then it has to be this one, but then that forcing that one means this red has to include this, which means this is red, this has to be yellow, and this has to be yellow, and I don't know how this works, and this doesn't work. Uh, it's rolling so well, and then just suddenly it's just like a brick wall, which like slams me and is like, no, this doesn't work. Ah, this. What am I missing here? What am I missing? I mean, this is everything logicked out perfectly, and then just suddenly it doesn't anymore. It can't be this. This can't be red because again, unfortunately this requires this being 3. Uh, everything fits. It's just. Uh, I'm pretty sure all the logic is correct that I did. I just double checked it and it's okay, let's do it again. Let's go through it again because it's obviously something is wrong. Something is wrong here, and I'm not sure what. Okay, a digit inside a square indicates the total number of cells in the same region that see that cell by knight's move. There's only 2 here, so this is 1 or 2. Similarly here, there's 1 or 2. Indicates the total number of other regions. A diamond indicates the total number of other regions with at least 1 cell seen by knight's move from that cell. So this is 1 or 2, this is 1 or 2. This has to be 1 or 2. This then has to be 3 or 4 because of the 1 2 1 2 pair here. Maybe it's this one. I don't know. Maybe something about this one is just, not correct, which I don't see it, but so this has both a square and a diamond, right? This technically is 1 through 4. This is technically 1 through 4. This is 1 through 6, but no 2. Can this ever be 2? No, it can't be. A digit inside a square indicates the total number of cells in the same region that see that cell in the same region. So that's 1 and 1. If this is 2, that would mean both of these were in the same region, and 2 other regions would be in the same region. But those are other regions, and this can't be the same. So this has to be 1, this has to be 2, this has to be 1. It's guaranteed. So this is light. These cannot be 1. Again, for a circle to be correct, it's a sum of all digits in the same region. So it cannot have only 1 in the same region. And therefore, and also the circles cannot be in the same region as each other, because then it would be the sum of another digit with that circle, but then this would be also the sum of that same digit with the circle, and they can't do that. So this specifically has to be part of region, the same region as these two regions. Similarly, okay, maybe it's here that I messed up. I don't know. This cannot be the same region as this. Let's try it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If we try to make that the case, well, okay, let's try to make it without the problem. Okay, so if we try to make it outside of this, the problem is it blocks this off into a separate region. So if we try to make it with this, the problem is that's too many digits. Can this ever be part of green is the question, actually. The problem is if we try to make it this way, say, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. That works as a region, but then this cell is blocked off. Wait, does it have to be there? Maybe this doesn't have to. Maybe it could be here. Maybe. No, but then this has to be. Yeah, this has to be different region. That's the problem. It cannot be here because that blocks up this. Can this all, and we just tried making this all part of the same region. It's too, this is already 6, 7, 8. And then this would be 9. And then this would be 10, 11. So no, that's not possible. So again, we tried to make this part of the green region, and the problem is that breaks, right? So this has to be red. The green cannot be part of the red because we just tried that, and it has to include this, and then that breaks everything here. So this then has to have 2, which are the same region. It cannot, this has to also be red, right? Because if it's not, how does it connect? It connects to here, and then this would be part of that region? That doesn't work. So this all has to be red. And we tried going this way, but the problem is this has to go around, right? 1, 2, 3, 4, 5. It cannot be part of this region. So if we try going around and not through here, we get 1, 2, 3, 4, 5, 6, 7, 8, 9 already, and that's 10. So it cannot go this way. It has to go here. Similarly, this has to go here because, again, this cannot be part of the same region. This has to be red because this must be adding up 2, and therefore they must be red. Cannot be here because that's blocked off. This is the sum of, this can't be light. This is the sum of 2 digits, and it can't be here, so this must be the same as this. Well, that essentially has to connect here. And this, we don't know how it connects. So this can only connect this way because it can't connect around here. So this has to be green. This can't, This is a square and a diamond, right? Yes, so it has a square and a diamond. So it's... I don't see how it could be any other... it's a square and a diamond. It's a square and a diamond. And a diamond! Which means it has to be 2. This can't be green because it would be too long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it would have to include that. That would be 11. So, no. These two both have to be, right? Because it has to be the same region. Yeah. Well, okay, no, this technically could not block. This would have to be part of the same region, right? You can't have this be the same, different region, right? This is a different region. What is going on here? Why is this? It cannot extend here because then, yeah. This can't be 4 because it can't extend this way. It's so frustrating. Where am I messing up? Where am I messing up? I'm obviously messing up somewhere, but I don't know where. That's what's bothering me so much because I keep running into the same problem. Maybe I need to take a break. I mean, because this is frustrating. Because uh this obviously cannot be light. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can never be part of this cell. If it's 3, right? 4, 5, 6, 7, 8, 9. Nope. So this has to be separate from this. This cannot be same as this for similar reason. I mean, yeah, right now, every single clue is driving me toward there, which leads to a contradiction, which is really bad. I'm just obviously missing something obvious here, that's frustrating. It's just like, how can I be missing something so obvious here, right? This is within a diamond and it's within a square. The total number of cells in the same region has to be at least 2, because it can't be 1 anymore, because that's the problem. This 1 forces this to be a 2, which forces this to be a 1, which means this is at least 2. Can it ever be? Can it ever be 3? No, because if you have 3 cells that are Knight's Move in the same region, you can't have 3 other regions containing a cell. So it has to be 2. So then this has to be 2. This cannot be 2. This cannot be the same region as red. We've tried to make it the same region as red so many times, and it just doesn't work. Therefore, since it's not the same region as red, it has to be 3. So therefore, this becomes 3. Which does mean that all of these 3 that are Knight's Move away are the same region, which forces this to be 4, which makes that have all the Knight's Moves that are essentially the same region. This can't go anywhere else except here, therefore that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a full region. Where am I missing this? God, this is annoying. Okay, this can't be... This has to be dark. Again, we're still running into the same problems. This is a full region here. This dark has to connect, so it has to go here, which blocks off the green. Oops, that's not the correct color. We tried to make this as part of this region, but that doesn't work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's already 10 if that's the case. In fact, actually, what is this region? I think it has 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this has to be part of it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. If it goes that way, that's blocked. So this almost certainly has to be here. And it's either one of these two, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and one of those two. So these has to be a separate one, which makes that dark. This has to connect somehow, so this will always be here. This can be a separate region, so we don't know. One of these two is... Oh, this... well, this could be dark and this could be light. The medium gray. But this is so problematic. This is not part of that region. Again, it's this thing. It's this specific square which is bothering me because it's saying this has to be green, which forces this to be red, which means this has to connect that way, which means this is blocked, which means this has to connect this way, but this is yellow, so therefore, this definitely has to be yellow. Because there's no other way, no other thing it can go to, right? No, because it's blocked by everything else. This could be red or yellow. This can't be red because that's another problem. This can't be red because these can't be in the same region. So this can never be essentially the same as yellow unless this is not yellow. But why? Why is this so hard? It's not even hard. It's just basically I keep running into the same brick wall, which is telling me this has to be the way that it is, but then the problem is that it breaks. What am I missing? What am I missing here? This has to be a 3 because this can't be the same as this region. This has to be a 1 because that has to be a 2 because this has to be a 1 because it's the same. It's a diamond in a square. And it's just, this is so frustrating. I don't know what's going on. I don't understand. It will always come back to this, though. That's the problem. If this is red, these cannot be red. These just can't be red. So therefore, this must be red, which means this can't go this way, which means this has to go this way. And if this is yellow, the problem is this becomes a red. This has to be yellow because of this, and this is blocked off, and this has to be 9. But then this green doesn't work because this one specifically, the square, breaks. Because it cannot go this way, because this has to be essentially those two. This has to be those two. This can't be part of yellow for the same reason, right? As the gray, as a dark gray, right? 1, 2, 3. Well, that's problematic too. 1, 2, 3. It cannot be part there. 1, 2, 3, 4, 5, 6. 1, 2, 3. Actually, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then this becomes non-2. Right? Because if it has to be red then. It's just... This is so frustrating. This definitely has to be part of green. We tried to make this part of it can't. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. It requires additional 1 because it has to be 2. And even then, that it breaks this red region because it can't. This region can't be 9, so that's problematic, anyways. Again, we tried to make this part of it, and that broke too because it had to go this way. But then the problem was this would be essentially both green and not red. And then we tried to make this part of red and green, but that didn't work because there was too many too many cells. It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So it's too big. Just kept on trying and this is just broken. It just doesn't I'm missing something obvious somehow, but I don't know where. Because this square, it's specifically this square, forces this to be a green, but then that forces this to be essentially not. What if we just Let's make this a yellow. Let's make this a yellow. So then this has to be yellow. We're gonna try to break it, I guess. This can't be red again because of the same problem. So these are all red. This has to be green. This has to be green. How does this even work? I don't even know. I don't think it does. These are separate. This is 1, 2, 3. Yeah, this is already just too big. I guess it... No, it can't be because this has to be 2 in the same region. Well, can't be here, can't be here, can't be here, can't be here. Can't be here. Can't be here. Has to be these two. But then this breaks. It keeps going. It keeps going to the same problem. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, one of these is yellow. Therefore, this would be all blue or the same blue. This can't be. This could be blue or orange. That's fine. This could be blue or orange. That's fine. Whatever. This is blue or yellow. This is yellow, blue, or orange. It's just, this just breaks. This breaks here. It's just like, so it's either this part or it's this one that's breaking things. So actually, this is still problematic too because it's really this circle. This circle is the one that's causing problems, right? Because it's saying this cannot be extended this way, right? Because it can't be, this would be 4 and 5 and 4 and 5 at minimum, plus another 1, which would make this 10, which is not possible. So this circle, actually, that's causing the problems. Every other thing is fine. It's just that this circle is causing problems. Unless obviously, assuming this is a valid construction, which I'm assuming, this already got good ratings. So this has to be a valid construction. So the problem is I'm missing something, but it doesn't. It's everything. I've triple checked it now, and I still don't understand what I'm missing. Like, what exactly am I missing here? This cannot be here, 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 or here. This cannot be here, 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 here. So it has to be it has to be those two, has to be those two. They're all part of the same one, but this breaks because this is too small. It's just, I don't know. I don't know what's going on. It's this circle that breaks everything. And that's what's confusing me then. Because again, I've triple checked it, going through everything in detail, and the logic seems to make sense to me completely. But it's something, I'm missing something here, and it's so frustrating because I don't know what I'm missing. Because even this way, it's still not, I don't think it's... Well, let's go through a fourth time, because I really don't know how else to go through here, because it's just, you have a diamond and a square. A square indicates a total number of cells in the same region that see that cell by knight's move. This can be only 1 or 2 here. The digit inside the diamond indicates a total number of other regions with at least one cell seen by knight's move from that cell. This only has two that are knight's move away. So this is also 1 or 2. Similarly here, this is 1 or 2 because that's a total number. This is a square. This is a square. Total number. Total number. Diamond. Total number of other regions. So if this were 2 of the square, that would mean the total number of cells in the same region. So these would all have to be the same region. But then the problem is you would have 0 other regions with at least one cell seeing a knight's move from that cell. So this definitely has to be 1, which forces this to be 2, which forces this to be 1. So one of these has to be seen by the same region. So frustrating. Can this ever be 3 or 4? No. It's a square, so if you see 3 cells that are in the same region, that leaves 1 cell which can be seen by other regions, but then they would not match. If you tried 4, you would have 0 cells, so therefore this has to be a 2. It's just, I don't get it. This then has to be 3 or 4. There's only 4 knights moves away from the cell. So again, it has to be 3 or 4, and this has to be 3 or 4 because again, there are only 4 knights moves, cells that are knights moves away from it. And squares indicate the total numbers in the same region. A circle, again, cannot be in the same region as another circle because then they add up to each other, but they're in the same region, so it can't be the same digit. So therefore, you can't have them be the same thing. And in addition, you can't since they are the sum of all the digits in the same region, it can't be just 1. So therefore, this must have essentially be in the same region as these 2. This is a separate region. Assume this was 3. Can this ever be in the same region as the light or the dark? Well, this says there are 2 other regions with at least 1 cell seen a knight's move away. So this cannot be part of that. So if this were part of this region, you'd have here, here, here be the connecting. So that would be 1, 2, 3, 4, 5. You have to connect it that way. That's the minimum. 6, 7, 8, 9. That's not possible to connect that way. What if we tried connecting here? We'd have 1, 2, 3, 4, 5, 6, 7. This is 8 and 9. So this cannot be the same as this region. So these are separate regions. These specifically are separate regions. Can this be the same region as this? Obviously, this could be the same region as this. This could be the same region as this. Can it be a separate region? I don't even know. If we tried to make the... Oh, no, it can't be, right? We just showed from using this that this can't be the same region because it requires too many cells. So again, if we try to make this along here, the problem is, well, this is a problem that, well, no, it could connect that way. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, and then we have 8 and 9. So it obviously can't go that way. Can the green be the same as this cell, right? Well, if this is green, what can these cells be? If you go here, that will block things off here. So this has to be green. If you go here, well, this is problematic because it's too large. So this has to be green. And therefore, this has to be green too. The problem is this requires two. So we already have those two cells. This requires two cells. It cannot be this one. Actually, this might work. Maybe this is what I messed up. Can it be these two and not have this one? One, two, three, four, five, six, 7, 8, 9, 10. No. That's why. I was just like, no. I did not mess that up. I really didn't mess it up that badly. Yeah, this requires 10. So this circle would require those two. Well, this one has to connect somehow to these two, somehow. So we again try to do that. It cannot be 2. Even then, it still requires 2 digits. So no, these have to be separate regions. And again, this has to be a separate region. This is a separate region, so this must be red. And we showed these have to be separate regions, so this must be 3, and it's the yellow, and we run into the same freaking problem over and over again. This requires 2. This cannot be the same region as this. So if this were green, it would have to be here and here, but that would block off the red. So the red region would be stuck. Therefore, this can't be green. This has to be a separate region. It therefore has to be red. Because if we try to make it orange, how does this connect? It can't really connect, actually. So this has to go this way. Because this is a separate one, again. So this has to be red. Which means it connects there. It can't connect to here. Because this is a separate region. So it must connect to here. And we keep running into the same problem. This, again, cannot connect to these two. These can't be the same region, so it must specifically connect to here. And therefore, because of that, we know it's the part of the light region. This can't be any other one because it would cut off if it's not, so therefore, and this would cut off if it's not, so therefore these are part of the light region. And we keep running into the same problem. This can't go this way because it's too. This can't even be part of the gray, of the light, so this doesn't even work that way. So this has to go here, which means it connects that way. And it's the same problem. It's the same freaking problem over and over again. And I don't see how you get out of this. It keeps going this way over and over again. This can't be 3, so that must be 4. Why? Why does it keep going this way? And this is 1, 2, 3, 4, 5, 6, 7, 8. So it must go here. Actually, it's really this. That's the problem. Well, it's this or this or this. One of those. But it keeps running into the same thing. Can't go that way, has to go this way, has to go this way, has to go that way. And I just don't know. I don't know what the solution is. This is separate, this is separate. This is separate, this is separate. We tried to make this as part of gray. That doesn't work. 1, 2, 3, 4, 5, 6, 7. If we tried to make this 8, this is 9, 10. There's only one of these can be, so therefore this is separate. We try to make this part of yellow, but the problem is you still have run into the same problems, right? This is 2. We're missing one here, and one of these is split, so this has to match the red or yellow. Which means this is red or yellow, but then this is... I keep running into the same problem over and over and over and over again. This has to be green, because there's no other place for it. Again, this cannot go here because that blocks that off. Cannot go here because that blocks that off. It has to go here. Which means this is a 1. Because this can't be in the same region. This can't be, this can't be, this can't be, this can't be. It has to be here. I'm almost giving up here. If this is yellow, both of these have to be yellow. But this would be 1, 2, 3, 4, 5, 6, 7, 8. And then this can't go down because this would not be a connected region. So this can't be yellow, therefore this is red, which makes both of these red. Because this has to be red. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that region is complete. Which means this is yellow. And this has to be yellow to extend. This is green. This would be all pink. It just doesn't matter. Because we have this problem here. This has to be yellow. This again. Cannot see. Has to be part of these cells. This has to be part of these two. Because they have to be. So therefore they have to be the same region. Therefore, this does have to go this way, which means this has to be equal to 4, 5, 4, 5, plus another region, another cell, which breaks it. Yeah, I've gone through this 4 times, and it's just, it keeps going down this path over and over again. I must be completely missing something. Well, obviously I mean, well, not obviously, because I keep getting the same logic. That's the frustrating thing. It's just like I can't, and I don't know, yeah, maybe it's just a blind spot on my part where I keep running through the same thing and it's something obvious and it's something that basically I'm just not seeing. Okay, I'm gonna take a break because this is so frustrating. So I'm gonna stop this video. Um, I don't know. We'll see if I can solve this in another part of the video because this is so frustrating right now because I am not seeing what I'm completely obviously missing. This would be 4, 5, 4, 5 plus 1. And anyways, that would be problematic because then this would have to be 3, 6, which would add up to 9. And this would be at least 9. It's it's just running into the same problem over and over again. Anyways, yeah, I'm stopping this because I'm just going in a circle over and over again. Okay. Uh, hope. Well, I don't even know what I hope for now. I don't know if I hope that this continues because then that would mean that I would be missing something really, really obvious, or I don't complete this because obviously I didn't solve it. Then, anyways, I'll see you next time on Frank Puzzles. Take care.